So today we're going to talk about inverse square law and calculating flash power. There are multiple ways to calculate the flash power and to identify how it's illuminating your subject. As you can see on this slide, first is using the guide number that comes with your flash. Second is the inverse square law, and 3 is a histogram. So let's take a look at what each of these mean. So guide numbers to start off to calculate your flash power. When you look at the flash that you have, every flash has a little bit more unique guide number, and that is a measured distance at which the flash can illuminate a subject, and that flash manufacturer determines that guide number. So these guide numbers vary anywhere from 24 up to 120, depending on that more powerful flash. The smaller the flash, generally the smaller the guide number. So let's say your guide number is 80. And the distance is 20 feet. You can calculate your f-stop for that image based on the formula provided on this slide. So your guide number equals distance times the f-stop. If you divide distance and pull that out of the formula, put it underneath the guide number on the left side of the equal sign, then you can have the f-stop equals guide number over distance. So you can calculate that. A couple of the flashes I own, the Olympus, $300 flash, it has a guide number of 36. The Yongnuo, less expensive flash, has a guide number of 190. So you can see that guide numbers vary tremendously and price does not always have anything to do with it. So I could, if I was shooting a subject and know the distance, I could do these calculations in my mind to determine what f-stop I would want for the appropriate amount of flash. Or I can take a look at the inverse square law. You have an additional video that we've recorded to identify inverse square law, but here's a quick overview again. So according to the law, the power of the light will be inversely proportional to the square of the distance. So with the formula I inverse square law equals 1 over distance squared. If you have your distance of 2, that gets squared to be 4. And you have the inverse, which is 1 over 4. So that means you end up with a quarter power at the distance of 2 feet versus full power at the distance of 1. The diagram on the slide here identifies how light spreads out, and that's why it is exponential in the difference in the light, because the light is spreading in all directions, not through like a flashlight would do through a tunnel. Here's some examples of what the flash looks like and how it's illuminating our subjects based on that percentage. And so starting 0 versus 1 feet, 2 feet, 3 feet down on the bottom of the screen. So at 10 feet, you have 1/100th of the power hitting your subject. How does that affect when you have subjects close up? So if they're going to be very close, you might stop down your aperture to get the appropriate light on your subject. And if they are further away, you could open your aperture to have the same amount of light. So both of these images could have the same exact histogram if you change each aperture according to this diagram. So when you're working with groups of people, notice in the diagram on the bottom, if you have 3 people in a line, it's a real difference in light illuminating the person that's closer to you at 1 feet versus the person that is 3 feet away. So how do you get a good exposure? Well, you're really not going to with them in a line like that, 1 to 3 feet away. If you want to get an equal exposure on all of them, you need to move them further away from the light where the fall off is less significant. And then the last option is to look at your histogram. So we can sit there and calculate guide numbers. I generally don't want to do the math when I'm sitting there taking photos. I also don't necessarily want to calculate the inverse square law, but I do understand it's exponential how the light falls off. So if it's easier to have a person move a half step closer or further away, depending if I need just a little bit more or a little bit less light, that might be my easiest option. You can also look at your histogram to identify if you have the appropriate amount of light in a frame. And so it's up to you really how you do it. I find changing the distance, and then also you can increase your ISO if you need more, or decrease the ISO if you need less light. So that's what it is about kind of calculating that flash power and deciding what is going to work best when you take an image.